Hello everyone, this is Revati M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are discussing about the introduction and programming of data science. Today, we are going to discuss about the introduction to the iris data sets. So, we are going to learn about a very famous data set in data science called iris data set. This dataset was introduced by Ronald Fisher in the year of 1936. So in the year of 1936, it contains 150 samples of iris flaws, and these flaws are divided into three types. One is setosa, vesicolor, and virginica. So these are all the three species we are using in that flower. So that is this data set is mainly used for classification problem, and it is a very helpful for beginners to understand machine learning concepts. Next, we see the features in the data set. What are the features we are using in this data set? Each flower has four measurements: sepal length and sepal width, and petal length and petal width. So these are the four measurements we are using in this flower. So using these four features, we can identify which type of flower it is. Okay, so the four will use to identify which flower of is this. But when the number of features increases, it becomes difficult to visualize the data. This problem is called high dimensionality. So here features in the iris data set, this flower contain sepal length, petal width, petal length and sepal width. So these four are used to identify what flower is this and why we are using. Okay. Next we see the standardization of data. So before applying PCA, we need to standardize the data. Standardization means covering the data so that the mean becomes 0 and the standard deviation becomes 1. So why do we do this? Because PCA is sensitive to scale. If one feature has larger value than others, it will dominate the result. So we make all features equal in scale. So we have to standardize the data before because it is sensitive in scaling PCA. So we are using the standardization of data. Next, we see the covariance matrix. Next, we calculate the covariance matrix. It tells us how two variables change together. So if covariance is positive, both features increase together. If it is negative, one increase while other decrease. Okay, so two variables chances together. One is a positive covariance and another one is a negative covariance. So here increase together, both are increasing. So in negative covariance, one increasing, another one is a decreasing. So these are all the covariance matrix. Next we see what are the benefits of PCA in iris data set. Now let's see the benefits of PCA. PCA reduces the number of features without losing much important information. It makes visualization easier, especially in 2D or 3D. It helps us find important patterns in the data. It also useful before applying machine learning models. So PCA simplify the data sets. Next, we see the limitation of PCA. So PCA also has some limitation. After applying PCA, we lost the original meaning of features. It only works well with linear data. It is sensitive to outlier and it requires proper scaling before us. So it's a loss the interoperability, linearity and outlier sensitivity and feature scaling. Next, we see the real world application. So PCA. PCA is used in many real world applications. It is used in image compression to reduce file size. It is used in face recognition. It is used in bioinformatics for gen analysis. In finance, it helps the risk analysis, and in machine learning, it is used for feature reduction. Okay, so in machine learning, we use it for feature reduction. So PCA is very useful in practical scenarios. We come to the end of this section. Let's conclude the topic. PCA helps in reducing the dimensionality of data. It allows us to visualize complex data easily. In the iris dataset, the first two principal components capture most of the important information. And overall, PCA is powerful pre-processing technique in dataset. I hope you enjoy this section. Thank you.